Hi Spring fans! In this installment of Spring Tips, we're going to go ahead and take a look at Spring Batch. In particular, I've delayed looking at Spring Batch before because I wanted to make sure we could cover some of the niceties that were proposed and already included in the first milestone for Spring Batch 4.0. So we're going to take a look at a simple example here today. We're going to go ahead and build a batch demo, starting with the Spring Initializer, as we always do. I'm going to go ahead and use Spring Boot 1.5 RC1, not because you need Spring Boot 1.5 per se, but because that'll give me the snapshot and milestone repositories, which then I can use to draw the milestone for Spring Batch itself. So let's use the MySQL driver. We'll use JDBC support here. We'll use batch support as well. And that I think will do. So we'll go ahead and hit generate. That'll give us a new project, which I'll start again, generate a new one. Open this up in my IDE. So what we have here is a simple Spring Boot application, as usual. In order for us to work with Spring Batch, we need to opt in. We need to activate it. So we say @enable batch processing, and this sets up the auto configuration. It activates the auto configuration, which in turn sets up all of the Spring Batch infrastructure. Because Spring Batch is meant to run long-running jobs, right? Spring Batch is a way of modeling batch processes. Batch processes, by their very nature, are long-running. They're stateful, and so you have to keep that state somewhere. Spring Batch does that in a SQL database for you. It'll install all the requisite metadata tables for you if you want as well. So it'll do that on application startup, which is why the first thing that we need to do is to point it to our data source. So I'm going to go ahead and just copy the properties here that I've already got laying around on my file system, and we'll paste that here. So there's my setup for my local machine or my local data store. It's a MySQL instance, and with that, I'll have a data source that MySQL data source that Spring Batch will know to connect to and to configure. Now, Spring Batch is just like any other batch processing system. It's very similar to anything you may have worked with in the past, including sort of more antiquated mainframe kind of technologies like CICS, COBOL and CICS. So in that world, there's very common jargon, very common sort of domain knowledge that's required to understand and work with batch processing. What batch processing is optimized for is dealing with lots of or large amounts of sequential data. So in the world of batch processing, you have this idea of a job. An operator typically runs the job. In our case, Spring Boot will run the job for us. It'll look for any jobs in the Spring application context when this Java process is started, and then just run them. You can explicitly kick them off, perhaps in response to an event like a web request or a message arriving or something like that. But the default behavior with the Spring Boot auto configuration is to run the job on application startup. Then a job itself is made up of several steps or stages. Each step takes data from some sort of source, it reads it, optionally then processes it, and then writes it out. So you do this in as many successive steps as you need to arrive at a result. So you might take data from a file system and then put it in a database. That's like the basic ETL kind of processing, right? And then you might analyze that database and then process the results and then write that out to another file, right? This is very, very common sort of batch processing. And if you're using Hadoop or COBOL and CICS or anything else like that, you'll recognize the basic structure of a batch processing job. So the first thing we need to do here is to build a job. So we're going to build a job using the Java configuration and the Java config API. So we're going to use the job builder factory, JBF, and the job will have multiple steps, so we'll build that using the step builder factory, SBF, and we'll tell Spring Batch to create a job called ETL, right? And the job will have an incrementer, that is to say, a unique ID will be automatically assigned to each job, because remember, by default, it's going to look at the parameters that we use to kick off the job and then use that as a way of sort of assigning it a unique primary key. So when Spring Batch launches a job, it looks at the parameters that go into that job and it uses that and stores it in the database. So if we then try to run the same job with the same inputs, it'll say, well, this is already running. You've already run it, or it's already running, so we can't launch it again. So for our purposes, since we're going to be iterating right now, we'll make it just automatically assign a new ID on each run. Okay, so the first step that we need to do is to describe a step, right? So we'll say step s1 equals sbf.get. We're going to say we want to read data from a file. In this case, we have a file here, cat desktop in.csv. It has names, ages, and emails, right? This has got only, what does this have? 10,000 records. So it's a small file, but it allows to go fast. The beauty of Spring Batch is that it's optimized for large amounts of data. So it's not going to do anything naive, right? It's not going to try and load, it's not going to do a select all, for example, on a database. It's smart enough to curse through the results. For example, if you're using a database, so even if you have 1 million records, the code will still work. If you have 1 billion records, the code will still work. Spring Boot, Spring Batch has a built-in support for parallelizing and dividing that work as well. Spring Batch has this notion of a chunk. So as it reads through the data, it goes, it reads a buffer, a large buffer, what is called a chunk, and then it tries to write that chunk to the writer. Right? It'll read as much as it can and then write, and then read as much as it can and then write. We can tell it what size chunk we want. So we're going to call this file to database, or just file to DB, right? And we're going to tell it they want to create a application that reads data from our file system and turns it into a POJO of a certain type. So in this case, we're going to create a POJO just called person. Now, if you're using modern language like Kotlin or Groovy or Scala or something like this, then this tedious code generation that we're doing here is not something you have to worry about. But for our purposes, we're using Java, and I could have used Lombok. That would have been just fine as well, right? It would have been at the equivalent of add data and just the fields, and it would have been done. But whatever, we're fine. So we have a field here, and we're going to take the data from the file system, read it, and turn it into records of type person, and then write it out from records of type person to the file system, or to the database. So, the input is person, the output is person. Then we're going to say that we're going to read records, or rather write records in chunks of, let's say, 100 records at a time. Now, again, you want to fine-tune this. This is a knob and a lever for you to play with in order to arrive at the most efficient system. The goal here is to not overwhelm your Java process. If you're reading 1 million records, it might be fine to go 1,000 records at a time. Another thing to consider when you specify a chunk size is how many records are you willing to sort of mark as incorrect and move to the side, right? The way that Spring Batch works is it has different settings, different things you can configure in specifying what happens if a particular chunk of data fails to read or parse or to be processed correctly. If something goes wrong, during records 999,000 to the all the way to the end, for example, to the last million, do you want to stop and do you want to fail the whole job, or do you want to just fail that chunk? Do you want to just note that particular chunk has failed and then allow the job to succeed, right? These are all things that you have to take into mind when you describe and build a batch job. And thankfully, it's easy to do that, right? So you can mark, for example, a certain chunk, if a certain chunk fails, that it should be noted in the metadata tables, and then an operator can come along and observe that. So we're going to say chunk of size 100, and then we need to tell it how to read the data. So we are looking for an item reader of some sort, right? We'll create a parameter here, item reader. Okay, like so. And we're going to also write the data, so we're going to use an item writer of some sort. So let's create that as well. Okay, and we'll build that. Now this is our first job. We'll tell Spring Batch about it. And we've got our first step there. We need to actually describe these item readers and item writers now. So let's go ahead and define a few beans. Now this is one of the nice features. This is where we get to look at one of the nice features in in Spring Batch 4.0. The builders. You see, Spring Batch has a very rich collection of item readers and item writers, and they do all sorts of different things. Right? They can work with all sorts of different things like long XML documents, Neo4j result sets, JDBC result sets, LDIF data, JPA, JMS, batching kind of stuff, etc. Right? So there's flat files, CSV files, messaging, Hibernate, all these kinds of item readers and writers. But there are some very common ones, especially in the domain of batch, like JDBC and like file persistence. So in this first milestone, which has just been released last week, there's already support for reading and writing. There's support for builder APIs to express a reader and a writer for working with file systems and for working with data sources, among others. And there are more on the way as we march towards a GA release. But I, as somebody who loves Spring Batch and worked with it for years, am super happy to see these builders arrive, because Spring Batch is a fairly old Spring project, as Spring projects go. It's been around since 2006. It was co-developed by the Spring team and I think it was Accenture, and that work was born out of customers who had use cases related to moving and migrating batch workloads. So it's been used by some of the biggest and the best in the world who are trying to solve these kinds of batch workload problems, and so it's very bulletproof. It's very stable, but it also was developed in the time when the XML configuration format for Spring was prevalent and basically the only way to go. In recent years, there's been a Java configuration API in terms of the job builder factory and the step builder factory approach and this, the Java configuration. All that stuff was added in recent years. But one thing that remained very much oriented towards the XML configuration, where you would specify lots of different properties on a bean, were these various item readers and item writers, which meant that each time I wanted to define an item reader and an item writer, I'd have to say set this, set that, set this, that, etc. And it gets a little overwhelming. So now it's very nice to have these convenient builders. So let's see. The first thing we need is a flat file item reader of type person. So we're going to call this a file reader. And we're going to use the flat file item reader builder here. And that comes in Spring Batch 4.0. So we need to specify that we want our Spring Boot project to use that version 4.00.m1 in lieu of the default one, right? So here we're overriding the default Spring Boot imported Spring Batch iteration, right? So there we are. There's our flat file item reader. I'm going to specify a few things. The first thing we need to specify is a name. So this is going to be a file reader. The second thing we need to specify is the resource. What data are we reading? Right? We want to read data from a file system, a CSV file, which we've seen on the console here, right? So we need to specify what that resource is, and we're going to just have that be a parameter called input, which will be provided into the Spring Boot application, right? So input. This is a Spring Framework abstraction, a resource, a Spring Framework Core I/O resource, and so as you know, in Spring, there's all manner of different resource implementations for different things. So bean definitions, class paths, file systems, VFS, URLs, path, based on Java 8 and so on. So lots of, or Java NIO rather, lots of different good options here. So it doesn't matter which one you use, you can specify that, and Spring Batch will just grab the input stream and read it for you. So here we go. We've got a flat file item reader. We want to map it to a bean, a POJO of type person, and we want to read the data that is delimited by a comma and that has columns, right? So the columns are the first name, the age, and the email. So say first name, age, and email, like this. And then we should have everything we need. This will throw an exception, might possibly, so we'll specify that as such. So there we go. There's our flat file item reader. That'll be the bean that gets provided or injected into this bean definition here. Now we need the database writer, the JDBC writer. So we're going to say JDBC batch item writer of type person, JDBC writer, and just as before, we're going to take advantage of a builder instead of doing all this configuration ourselves, right? So we'll say bring in the person, and we're going to tell it to use a data source. In this case, the data source is the one that Spring Boot will configure for us based on these specified properties. So we're going to be connecting to MySQL, as you'd expect. We need to use a SQL statement, so we're going to say insert into people, which is the table that we're going to create. Age, first name, email, values, age, first name, email, and then we need to we want to tell Spring Batch to use the field on the POJO that's coming from the reader. So remember, the reader is going to read the data from the file system and turn it into a POJO of type person. That's going to be then passed to the writer, which is going to inspect its properties, because we've told it to do so by using beam mapping here, and use that to resolve the parameters for the SQL statement, the prepared statement parameters. So there's that. We also want to provide no, I think that's it. That's all we need for this. So that should be enough. We're using a data source, so Spring Batch will create a named parameter JDBC template based on that data source for us intrinsically, although we have the option to override that if we want to. Now, we need to plug this all in and make sure it's working. It's going to expect a input parameter. So for our little prototyping here, let's just hard code it here. We'll say system.setProperty input, and we'll point it to the users JLong desktop in.csv .get absolute path, and again, this is using the special URL syntax for Spring's resource abstraction, so we'll take that. Later on, we're going to have an output CSV, so let's just go ahead and specify that here as well. There we are. There's our input and our output, and Spring Boot will turn those into properties that can be injected and resolved in the value using this value annotation. So that should work. That should be a very simple example. Of course, it's we need to make sure that we have database. So let's go ahead to our resources directory here and create a new file. New file. So we're going to call this schema.sql, and we're going to say drop table people, if exists people. We'll go ahead and configure a data source here, so we have an easier time of sort of interacting with our database as we build this. It's going to be the batch database, batch user, batch password. Let's test the connection here. Good, seems all right. Hit apply. Now we can interrogate everything, so we can see, drop table people, good, and we want to create a table. Now that we've deleted it on every run, so create table people ID big int 10 not null primary key auto increment. We need to say use MySQL here. Okay, good. There's that. There's our first field. We want another one for the email, so we're going to say email varchar 255 not null. I'm going to say another one for the age, so int 11, or minus 5 is more than enough, 3 even, it's more than enough, not null, and first name varchar 255 not null. Okay, so there's our simple DDL. We're going to drop the table on every start. So this convention here, this schema.sql, and if we had optionally, we could have specified data.sql. These two files are going to be read by Spring's basic JDBC support. This is not specific to Spring Batch. It's just very convenient in this case because we can have Spring install our table for us when it connects to the data store. So that means that we don't have to worry about that being present. So let's see. If everything goes to plan, we should be able to run this and then visit the console here and say select all from people. Right? So let's see if that should work. Okay. Looks like it's okay, maybe. Ah, something is wrong. The table got created, that's okay, but we don't see the data reflected in the output. I wonder why. So, we didn't specify a no argument constructor for the person Pojo, which is what Spring is going to map to the records, right? So here we go. Try again. Something else is wrong. Beam property is not writable, so we need to specify some setters as well. Again, this is all the kind of tedium that non-Blocker languages like Kotlin and Scala make dead simple to get past. Okay, that seems a little more promising, doesn't it? So let's see what we have here. Okay. There we go. We've got some data there. So age, email, ID, right? So the data has been written to the database. That's fine. Now I want to see, I want to see the distribution. I want to see how many people have a certain age, right? There's 10,000 records, so we're going to do a very simple query, and then we'll write that resulting data out to another CSV file. So we're going to do the same kind of thing in reverse. This is a single step. You can have multiple steps, right? And the way you connect these steps is just to say next, and then provide another step. Now, of course, you can also say on, and then specify a pattern that matches the status of the completed previous step, of the previous stage, right? So if you look in the console here, you can see that the job itself has a completed status, right? And each step also can return strings that tell you that can be used to sort of create workflow. You can do all sorts of really cool workflow kind of things, or job sort of flow decisions here. There's even the ability to provide a custom object that makes the decision programmatically, right? So, but for our purposes, it's simple enough to just leave it like this, just to have a step that one before the other. Another thing, instead of having a step, instead of having a step like that, or rather, instead of having a step that has a reader and a writer, your steps can also you can also use something called a tasklet. And a tasklet is a sort of a generic fall-through mechanism. It's an object that you can put in the middle of your flow somewhere, and it can be used to do something that isn't, strictly speaking, an item reader or an item writer. I also should mention that you have a third type of object here called a processor. Now, a processor is very simple. This is actually one of the cases where this is one of the classes in Spring Batch where you would provide most of the business logic. There aren't all that many very useful, if any, in fact, default item processors out of the box. Yeah, a lot of these are just wrappers or adapters. These are not things that do anything particularly useful. This is where you put business logic, right? So the contract here is that you get the person that came out of the reader, and you can do something to that person, and then that's what gets sent to the writer. So if you want to do any kind of enrichment, augmentation, transformation, anything you want, you put that business logic here. Maybe you wanted to go through all the records in a database and do some sort of calculation, and then write the results back to the database. So that could be the writer as another database, right? In this case, we don't need to. It's fine, right? So we've got everything we need. Let's go ahead and build a second step. So step S2, SBF dot get, and then here we're going to say db to file, right? Same thing as we did before, but in reverse. And what we're going to do is we're going to select all from the people table, and select the count, and then the age, and then group it by the age. So we'll get a mapping of age to how many people have that age. Now, we're going to express this in terms of a map of integer, right? So the key will be the age, and the value will be the count of that age. And so we'll specify map integer twice. Okay. Chunk, I'm going to do the same chunk size there. Bring in the map type. There we are. We need to specify a reader and a writer, just as before. And this gets us into a bit of a problem, doesn't it? We've got an item reader and an item writer up here, and we haven't really been very specific on the type. I could have downcast them to this specific type, but it wouldn't do us all that much good, because eventually, in a sufficiently complicated application, you very well may have multiple instances of a flat file item reader or JDBC batch item writer, for example. So using type disambiguation alone isn't going to be a great fit. You could use a qualifier. You could say this is you could use conventions based on the names of the method, or the bean rather, the name of the method or the name of the bean, like this. And rather this, you could say foo or step one, R1, whatever. But that all gets kind of tedious. One thing I like to do is to use sort of configuration classes. I like to have a kind of a wrapper configuration class for each step. So I say public static class step 1 configuration, and this is just a nested configuration class that in turn contains 2 bean definitions, and you get a free kind of scoping this way. The benefit is that now, instead of me injecting these 2 beans that I need directly, I can say step 1 configuration, step 1 config, and I can just dereference the bean definitions directly, right? So this is a natural thing to do in Spring. So what we're doing is we're saying, I want to inject the configuration class itself as a bean, and then I want to have access to the beans that are created from those configuration bean provider methods. But make no mistake, we're not actually calling the method. We're telling Spring to give us the returned value. You can do the same thing, from one bean to another. If I want to have my file reader call, this bean here, I could say call this foo, right? Whatever that is. There's no reason I couldn't just say this.foo and then use that bean. But that bean will go through the life cycle and all the initialization callbacks and all the stuff that Spring guarantees. And it would also be a singleton. So I could call this one method, this.foo, 1,000 times, and I'd only ever have, by default anyway, one bean. So we're doing the same thing here, but we're calling the bean, we're dereferencing the bean on the configuration class itself. So this is going to require a exception be caught, so we're going to throw that. And that gives us a nice little scoping, if you will, a little bit of isolation. So now we can define another configuration class for step 2. So at configuration, public static class step 2 configuration, and we are going to describe first and foremost a database reader. So we're going to say item reader map of integer JBC reader return new JBC cursor item reader. But of course we're not going to use the cursor item reader directly. We're going to use the builder to build that item reader. I'm going to return data in terms of we're using a map as a tuple here. So we're going to need a data source, of course. So bring out data source. Like so. And we'll give it a name. So we're going to say JBC reader. And then we'll map the data that comes back. So we're going to provide a new Spring, we're going to provide a row mapper, and this is very familiar to anybody who's ever used the JBC template in Spring Framework proper, which has been around since basically day one, right? The JBC template's very, very popular. The contract is very simple. It says when the Spring Batch component, the reader, visits a record, it gets it's looping through all the records. It's going to ask us to map that result set into something meaningful. In this case, a map of an integer, right? For keys and values. So we're going to say return collections.singleton map, and the data is going to be a result set dot get int, and it's going to be a for the age, and result set get int c for the count. Okay? Now this, of course, is a nice lambda, Works well as a lambda. So we can say, use that. We are missing something. Oh, we didn't build it right. No, of course not. So dot build. That should work. That should give us our data. It's going to map it into that. And I think that is everything we need for the reader. Now we need to write the data. We're going to take that resulting data and then write it out to the file system, right? So we need the SQL statement, of course, naturally. So we need the SQL statement to arrive at that computed, calculated data. So we're going to say select count age from, or count age C, age A from people group by age. There we are. So that's more like it. So the C will be the count, age A will be A. We'll turn that into a map, a singleton map, which has one record, one entry. So RS. It's actually fairly concise either way, isn't it? That's our reader. Now let's do the writer. So we're going to say item writer for a map of integer file writer, and same idea. We're going to write out to a file system somewhere. So we're going to provide an out. We're going to dereference our data through the output parameter here, and we'll say new flat file item writer builder of map of integer dot build, and we're going to provide this a name. So file writer. The names, by the way, are useful because, again, these components are going to be saved in the database. The state for the process, the progress for this job will be saved in the database. So we want to be able to checkpoint this, to be able to look at the database and say, oh, this got so far, right? So we need to give it a name. We could use generic names if we want, but it helps to be just a little descriptive. I'm being fairly opaque here. I mean, what is a file writer? In the context of this job, it's pretty clear, but if you have enough jobs, you may want to get more inventive when you do that. So we need to point it to that resource that we just described, and we need to provide a line aggregator. Now, the line aggregator's job is to figure out how to take the input data that's coming in from the file system and turn that into a set of records that we can, or rather, it's going to take the data that's coming in from the JDBC reader and turn that into records that can be written out into the file system as a line. So it's our job to turn the objects into a string, ultimately, right? But we don't have to do most of that work. We can use this delimited line aggregator. So we need to specify the delimiter. I think the default is a comma, or rather, a comma anyway, but it's never hurts to be explicit. And then we need to provide a new field extractor, right? So field extractor. And the contract here is fairly straightforward, right? Given a map, which is the input from the reader, return an array of values that can be then written to the output stream, right? So let's replace that. We'll say integer map entry set iterator.next. Since there's only one value ever, this is a fairly safe gamble. And what we're going to do is say next.get key, next.get value, right? So we're going to write the left column will be the count, the right column will be the or rather the left value will be the age, the right value will be the count, okay? And I think that ought to do it. Seems to me. Let's see if we need anything else here. You can specify encoding, the header, for example, how to manage or work with the header. Should things be deleted if it's empty, if it exists, and all this kind of stuff. Should we append to the file as opposed to writing it out a brand new file? So all of this is stuff you could specify, but I think for our purposes, it'll be fine to leave things as they are. So here we go. We've got our step 2 configuration. We've got a JDBC reader and a file writer. And we can do the same thing as we did here. Step 2, configuration. Okay. And you notice that I'm passing a null. Again, these don't contribute to the creation of the object. They're just telling Spring to call the method. It doesn't care about the parameters that we pass in because it's already got that bean, right? So this is, it's all just, we don't have to provide the parameters. Those are going to be provided by the dependency injection container itself later on, or perhaps earlier on in this case, because they're singleton, so they would have already been initialized. All right, so that I think should do it. So if everything goes correctly, we should be able to see on the file system here. Let's see, out, good. There's no out.txt yet. Let's go ahead and run this. Looks all right. Cat out.csv, and there we are. On the left we have the age, and then on the right we have the number of observed instances of that age. So it says here that the age 99 was seen 108 times in that input file. So in.csv grep 99 wc minus l 108 exactly. So it lines up with what we'd expect. Now this is a simple example. Spring Batch will do the right thing in terms of chunking. It'll go through the data and read so much, and then write out in a chunk that data to the writer. And this means that the code will work. It won't load too much data in memory more than it can handle. And all of the item readers and item writers are geared to work this way, right? The contract for an item writer is to take a list of n items, which is a known chunk size or less, and then write them out. Batch processing is by definition one of the things that you don't want to have to do yourself. It's the art of dealing with large amounts of data, such that if there's a bug in your processing code, you won't find it until maybe hours, right? Batch jobs could run for 24 hours. There's no reason a batch job couldn't take hours and hours and hours, or all night, for example, right? So you want to use as many of these sort of batteries that are included with Spring Batch as possible. The support that we've just shown here, the building a simple job, is just the beginning, right? In an earlier Spring tip, we looked at Spring Cloud Dataflow. You can actually orchestrate batch jobs using Spring Cloud Task on Spring Cloud Dataflow. So that is the subject for another video, I think. But this should give you a sort of quick introduction, quick look at Spring Batch. What you should appreciate is that this is used to handle sort of finite workloads that have a beginning and an end. And a lot of data still very much fits in that world, but a lot of things are also infinite, right? They never end. And for this, there's the capabilities that you find in Spring Cloud Dataflow. So if you look at Spring Cloud Dataflow, it is a amalgamation or a mix of both the batch processing support here in Spring Batch and the event-driven sort of infinite and never-ending stream of events support that you get in Spring Integration. It brings together both worlds and makes it as easy as possible to describe solutions no matter what the nature of that solution. All right, well, this has been a quick look at Spring Batch. We'll see you in the next video. Thanks for watching.